Hi, today we're going to talk about expected value and variance in context of probability theory. Expected value in mathematics is the same concept as mean and average value. So we talked about total uh, probability rule in our previous section. So expected value is based on that. So it's sum of expected return at each mutual exclusive scenarios, and these all scenarios are exhaustive. So it can be better explained using this example. So let's suppose we roll a dice, and whenever there is a even number, we make $1, and when there is an odd number shows up on dice, we make $2. So if we do this experiment multiple times, then you'll see the expected value which we make, it will converge to its average. Uh, so there's a 1/6 probability of happening, um, or showing up number 1, 1/6 for number 2. So for all the numbers which shows up on dice, the probability is 1/6. So if we multiply the value by its uh, probability, you can see the average, it comes down to 1.5, which is also an average. um, what is variance? So variance is sum of squared differences between each outcome and the expected value. So once we know the expected value, we say it's mean value or average value. If we uh, if we subtract it from each outcome value and take a square of it and multiply by their probability, we'll get to know the sum of squared differences, or we get to know the variance of the experiment. The standard deviation is just a square root of the variance, where they both are measure of dispersion, volatility of only one variable. So far we're talking about only one variable. Covariance measures two, is a measure for two variables. So it's a measure on how two assets move together, whether they are positively covariance or negative covariance. It goes from positive infinity to all the way to negative infinity. So if you see, this formula is very similar to formula which we saw for variance, but instead of taking square root, since we're talking about two event or two variables here, so we compute the expected value for each variable, and this probability is a joint probability, and so we multiply them by their joint probability to come up with the covariance. So covariance value, as you know, it goes from minus infinity to positive infinity, is very large number. For comparison perspective, it's not ideal. So correlation is a way to standardize this number. So correlation measure the strength of linear relationship between two random variables. Correlation has no unit. It lies between -1 to +1, so that it's easy to interpret. +1 represent perfectly positive correlation, and -1 represent perfect negative correlation. If correlation is 0, means there is no linear relationship, but there may be other relationship which may exist. So the correlation between A and B is very simple. The covariance we just talked about, divided by standard deviation of A and standard deviation of B. Thank you.